Well, thanks for having us. We're going to take just a very quick look at what we see going on right now, kind of some trends that we see, some things that we're reacting to, some of the things that are pushing us forward. That last presentation, which is great, is a great example of that. So we're really just trying to here, we're going to take a look just where we're going. I'm going to be presenting here. I'm business development for Rhino, and Luis is really involved with our development and our research arm of the company, and he'll be assisting me in this presentation. Generally, what we're going to look at is look at a general trend, an overall trend that we see happening in a lot of different places of this transition from files to workflows. We'll show how we think Rhino's evolving based on that, and we may, if we have time, look a little bit beyond that, but we'll see if we actually run into anything there. One of the things that's really important to understand that we've all been dealing with for a long time, and I think we took it for granted for a long time, is that we always had these files. We had these monolithic applications. We had files that we were one was talking to the other, and even in the best conditions, files are flawed. There's incomplete conversion. There's incorrect conversion between things. Files aren't very future-proof. A lot of times these file types are monolithic and very, very opaque, actually. Their scale becomes a problem. Single files can only be so big. And versioning is usually not that very sophisticated. And I think one of the things that we can look at is that a parallel to this is the team, the workflow, the teams that we're trying to enable, as KPF was talking about, are varied. There's varied expertise. The people are have many different backgrounds and expertises, and like file formats, we need to figure out how to get data and information from one person to another better. And so, it'd be much better if we could see a kind of an idea or a layout like this, where we have the different players, whether they're technology players or they're process in the actual production, or their decision makers, all working together from the same amount of data that's integrated together. Now, to do this, before we'd have to place a series of different applications for each one of those circles, and then we'd have to send files between each one of us, different files, whether it was CSV files or whether it was DWGs or whatever else, and all of that was incomplete, so that the communication between them was always terrible. What we've seen now, what's actually available based on modern programming tools, is now architects and engineers can actually start to write their own custom tools to enable specific workflows with specific teams. And that is something that I believe is becoming a requirement for any real professional service anymore. There's lots of applications out there. There's a lot of cheap applications out there. There's a lot of things out of the box that almost anybody can do. But from a professional point of view, and we're seeing this in lots of other professions, the ability to develop your own digital tools is very, very important. Also, teams are becoming more distributed, and so we can use technology to reach across that. And so what is interoperability? Interoperability, I think this is a really good definition, is the capability to communicate, execute programs, and transfer data among various functional units in a manner that requires the user to have little or no knowledge of the characteristics of those units. And I really like that. That works from a technical point of view, but I think if you stand back and you look at this statement, you can actually apply it to the team members too. And so, one way I might adjust this phrase or adjust this is I might rewrite it a little bit, saying capability for teams to communicate, execute projects, and transfer information among various team members in a manner that requires the user to have little or no knowledge of the unique technology behind the information. And so that's, I think in the end, while we talk all technology tools, I think that's what the kind of the driving force behind a lot of these solutions is the ability to enable people to work together without having to be Grasshopper experts, for instance, just to put it in simple terms. You can break this down. The idea of interoperability is that, you know, we used to pass files. Now we want to try perhaps to pass data. At some point, maybe we can pass functions, and then actually whole workflows can be passed from one piece to another. And we think that's a good way maybe to look at that. Another way to break this down is to look at monolithic applications. If we look at Rhino or any application, there's a user interface layer where you can maybe customize it. You can actually obviously use the product. You can look and look at data and information about it. There's a layer of computational piece, which takes the information and translates it and you know, executes on the commands. And the last piece is there's a data storage layer. If we take our levels of interoperability and we line those up, but we start to think about, instead of one application, we think about pulling this apart as pieces, similar to what we've done with Rhino Insight, is pulling this application apart and now approaching this from a piece. So you have your data layer, which is you know, let's say it's out in the cloud somewhere. It's not really a file anymore. It's more of a data structure. You have a layer of computational processing, a layer which we'll call functions in our interoperability idea that we're using here. And then the final piece is that some interface to workflows, some interface to so that the person can interact with that. One of the challenges we're having is that sometimes this workflows, for instance, wants to be on the web. But there's many times where people want to use Rhino and Grasshopper to do that. And those people may sit next to each other on the same team. And so, you know, this process is not linear. This process is not straightforward all the time. It's, you know, a little bit of the old style, a little bit of the new, you know, all mixed together. So how do we approach that? One of the things we've done is, you know, there's a lot of different solutions out there that are trying to do this. You know, everybody knows about Flux in the past, Construve, Speckle, Bohm, Hypar, all of them are kind of trying to pull this process apart and have different pieces. From a functional, that's in the data side. On the functional side, you know, there's Swarm, there's Shapedriver, Hypar again. Building habitats, object model starts to work with functions. Pollination from Ladybug Tools is also another product that's trying to pull these apart and, you know, create workflows and functions and things like that. And then there's many workflows that we're seeing, you know, Proving Ground Semantic, TTs, Carbon Calculator, things like that. And so you're starting to see a lot of these pieces kind of pulled together here. I think that you could look at this and see how this is now becoming possible. You know, the web itself has made this possible. I think that development of software plugins themselves have become much easier with the advent and the maturity of .NET interfaces. That, you know, no need to have to deal with kind of the arcane way of memory cleanup and things like that, and lots of open source products. A lot of this is now reachable and possible for people that aren't traditional developers and product or computer scientists. Now, so I believe maybe it's even becoming a requirement for firms that want to stay on the front edge. So we're starting to see, you know, AEC entities as software developers. We're seeing intelligent tools be created. people are trying to encode human effort, which is very interesting, trying to encode best practices. A little bit of AI in there is something that may be coming down the pike. The thing that we like is that while we're trying to pull Rhino apart and give people access to different parts and pieces, and Luis will go over many of those projects, I think one of the refreshing parts of this is that we're starting to reflect actually a more complex team, more complex project like these AEC projects tend to be, and quit being so siloed, not only with the project team, but also the software without the files and things like that. It's going to be a transition that takes a long time, but it's something that we're really aware of. So what I want to do now is I want to hand this over to Luis, and he can look at how Rhino is kind of reacting to some of these forces and reacting to what people have been asking for, and so we'll go from there. Luis?
All right, thank you, Scott. I have no idea how much time we even have left now. Charlie, do you have any?
Sure.
Any semblance of?
We started a few minutes late, 11:50. So let's give it another 8 minutes or so.
Okay. All right.
If you need
So
more, we might give you more.
Let's go to the next slide. No, well, it's fine.
That's okay.
So yeah, I mean, I think with what Scott brought up, we'd like to map this sort of interoperability units to what we've been doing with Rhino. So a lot of you are used to Rhino as a desktop tool, but actually since it was launched, there's always been a way to connect Rhino to other applications via our OpenNerbs C++ toolkits. It's been around for more than 20 years. Our C#.NET toolkit's been around for 5 years. And more recently, Rhino 3dm.js and .py really sort of give access to Rhino data in the cloud and a lot of other environments. So this, yeah, I mean, as a software vendor, we're interested in having Rhino 3DM data out there as files, of course, but you've always been able to interact with Rhino as kind of a data layer to other applications. And it's been open source for since it got out, but we had to learn how to make things open source, and it's definitely noticeable that in our with the advent of Rhino 3DM, JS, and Pi, there's definitely been more contributions to these libraries on GitHub. Next slide, please. And so yeah, one of the other things to make this easier to get Rhino visualizations on the web is we created a Rhino 3DM loader for Three.js. So this is one of the, let's say, example areas in Rhino 3DM, so through Three.js. So it's not like core Three.js, but you can always access it with a CDN. And we try to bring everything in as possible. There's still some work to be done with textures and materials, but right now you can bring all sorts of geometry types right into any web-enabled application through Three.js. Next, please. So continuing on this idea of data as interoperability, and we've seen companies and all of you try to connect Rhino in different ways. Of course, we know this ArchiCAD connection with Grasshopper that Graphisoft developed, and also Trimble Tekla did a similar connection. And here we kind of asked ourselves, what can we do to make these kinds of things a little bit easier? Next slide. Because here, there's no files anymore. There's just the data from one API going into the data of another API. So it just becomes this kind of just data transfer. Files are kind of left in the dust. Next slide, please. So there had to be some architectural changes to enable this to happen a little bit more easier. And this sort of happened between the Rhino 5 and Rhino 6 cycle, where what used to be one monolithic application, as Scott mentioned, got split up into something a little bit smaller. So something that runs this Rhino core.dll, and eventually this is what started us talking about this in a different way. This is really what's called Rhino, Rhino inside, exactly. So it's schematically looks like this. It allows us to completely forget about files and only operate on the data structure and data structure as a way to just make these connections easier. Next slide, please. So Rhino Inside essentially is an open source project, allows Rhino to run inside and Grasshopper to run inside other 64-bit Windows applications, such as Revit and AutoCAD. And we have a lot of other examples, but if you go to the next slide, please. I think the main one that most people here might know or might be interested in is Rhino Inside Revit. Next slide, please, Scott. And here we actually put our own developers to work. We have we have actually Scott's working on this. Ehsan and Kikir are working on this project, trying to just understand that community, and which is really when we started Rhino Inside, it's a little bit innocent. No? I mean, you can put Rhino inside other things, but then when you start to look at other applications in earnest, you see that it's an entirely different universe. There's different communities, different vocabulary, different expectations. So we can't spread ourselves too thin and try to get Rhino Inside everywhere, which is what we really tried to do at first. And we really focused here on Rhino Inside Revit. Scott's been doing a great job to put the documentation material together and to really understand that community. So now you can basically automate Revit from within Grasshopper, and sort of get the best of both worlds. You can leverage the power of Rhino and Grasshopper, the geometry that we provide, etc., and push that to Revit, where you can create all sorts of complex families, drive things with parameters, create amazing documentation. And I think we're very close to releasing a beta. I don't know if maybe eventually Scott might want to talk a little bit about this later on. I mean, anyone's been able to use this as a kind of a work in progress, but we're getting close to something that we would call, let's say, feature complete. Next, please. So because Rhino can run in other applications, we can make an application that serves the purpose of a web service. So that's exactly what Rhino Compute becomes. It allows Rhino to be accessed from, well, basically any device that has an internet connection. And here we sort of really kind of evolved from just passing around data to thinking about more encapsulating functions and having those be the interoperational units that people start to play with. Next slide, please. Like everything I've been showing here, Rhino Compute is also open source. You can see how we've done it and how we thought that some of the technologies that we thought were interesting to play around with. But as Scott mentioned before, a couple of the companies and platforms that we work with, such as Hypar or TT Swarm, are already experimenting and using this. And it's we always thank TT and thank the AECtech hackathon, because one of the aspects of compute being able to solve Grasshopper definitions was from what started here at an AEC hackathon. So we very much enjoy being part of this event. And because great stuff always comes out of it. And if you continue on, I mean, one of the important parts of Rhino Compute is that now your Grasshopper definition doesn't just need to run on desktop Rhino. It can become a function that can be accessed from anywhere. And to push this a little bit further, Steve Baer and a few others developed something called hops, which if you're used to clusters in Grasshopper, I mean, actually, I think Nicholas or Luke explained it a little bit better in the previous presentation, but it's essentially like a cluster, but it's a cluster that's looking at a different Grasshopper definition altogether. And by the way, it runs in a separate process. So it makes Grasshopper 1 now kind of a multi-process enabled platform. So now here we're really moving from functions, being able to encapsulate functions, but then all of these can become linked together into workflows. So these are some of the things that we've been developing. Another element that also was kind of graduated in the Rhino 7 release cycle, if you move to the next slide, these are really developer tools. that developers can leverage and make really interesting applications. But what about like the Rhino power user that isn't necessarily interested in getting into Grasshopper? Well, you can also leverage Grasshopper definitions in a different way. You can also use the Grasshopper Player to kind of convert that definition into a Rhino command. And you can actually get pretty crazy with the user interfaces. If you go to the next slide, as usual, our users kind of wow us with what they can do. And here is a particular user that Yellen, that made some crazy interfaces, like way beyond anything that we had imagined people would do with Grasshopper Player. So if you take a look at this Grasshopper/player/custom/tools wishlist, etc., and it's just a great thread of this user just showing like these amazing Rhino commands that are all driven from a Grasshopper definition. So, I mean, this is a story that we really like because, it takes people who've invested in Grasshopper and getting that skill set and getting that know-how and really pushing where they can be relevant. It can be, this definition can now be used on the web. It can be used within other applications such as Revit. It can be passed to other Rhino users as commands. You can actually compile Grasshopper definitions into Rhino plugins. So there's a lot of power here evolving from just thinking of Rhino as a file format, thinking of it as data, thinking of how it can become eventually a way to encapsulate functions and eventually a way to stitch together workflows. So I can go beyond, but I think we've gone beyond time. Maybe I think maybe just as a closing thing, another way that we've evolved. If you maybe you can go just 2 slides, and I'll just finish it there, maybe, Scott. So maybe one of the ways that we've evolved, as a company on a more meta level, is figuring out other ways to collaborate with our users. And one of the things that we've been able to do here in McNeel Europe is be a part of funded research projects in the Horizon 2020 framework, and now I'm trying to get some proposals for Horizon Europe. And we've been able to collaborate with users such as Herzog and Demuron, Zaha Hadid, hopefully soon Thornton Tomasetti, and others. And going beyond, what we can do as a software developer, going beyond what other partners can do as an architecture engineering office, but really, finding ways to make our industry better, make, it might sound cheesy, but actually make a difference in how, projects can be built and their sustainability factor. So this is something that I head up with a team here in Europe, and it's a really exciting way to actually work with our users in a much more intimate way, and do projects together. So I think maybe I'll leave it there. Find different ways to collaborate and find different ways to work with folks beyond just being a software developer. And yeah, I think that's how we can go beyond our typical